Hi everyone, it's Mrs. Bebo. In this part 2 of our video series on dividing rational numbers, we're going to take a look at evaluating algebraic expressions as well as a couple of story problems. So on this first slide, you can see we have two problems, both of which require us to evaluate these algebraic expressions. So the one on the left says evaluate a divided by b if a is equal to 3/4 and b is equal to -5/100. Again, with these questions, with these problems, like I said in previous videos, you can actually solve these using fraction form or decimal form, because this one on the left and the one on the right both have fractions that have a nice terminating decimal form. So it's totally up to you. For the one on the left, I'm actually going to change that 3/4 to 75/100. Because it's going to be a little bit easier to solve this question using decimals instead of fractions. But again, it is solvable using a fraction. And I will actually show that on the second one using fraction form so you can kind of see how both methods work. For this a divided by b now, if you want to, again, this is the same thing as just saying a divided by b. So we can write out our question exactly that way and say, all right, I have 75/100 divided by -500. Now, when I set up this question, that -500 is going to be on the outside of my long division. So we're going to have -500, and then that 75/100 is on the inside. We don't want to be divided by that decimal, so we are going to move our decimal point to the right 2 spots. And then what's really nice about that is that this question now just turns into 75 divided by -5. And so we can go through and do our long division here and say, all right, 5 goes into 7. That is going to be 1 time. And so we can subtract 5. You get a 2. Bring down our 5. 5 goes into 25 5 times. And so we get 15 as our answer. However, it was a positive divided by a negative. So officially, our final answer is going to be -15. And there's that question there. Now for the one on the right, again, it says evaluate x divided by y if x is equal to -6 3/8 and y is equal to -4 25/100. So with this question, like I said, I'm going to do this one involving the fraction forms. So I will rewrite this -4 25/100 as -4 1/4. And again, just like the previous question, this x over y, we can just write this as x divided by y, right? So we can write it so that it doesn't look like a fraction. And so setting up this question, we're going to have -6 3/8 divided by -4 1/4. When we divide with fractions, we do need them to be improper fractions, not mixed numbers. So we'll do 8 times 6, which is 48, plus the 3, which is going to be 51. So this will be -51/8 divided by, and then 4 times 4 is 16, plus the 1 is 17, so -17/4. So with this question, now that we've rewritten those mixed numbers as improper fractions, we can keep, change, flip. So we're going to keep -51/8 the same. We're going to change that division to multiplication, and then we're going to flip that second fraction to its reciprocal. So this will be -4/17. And now we can actually do some cross-canceling in both directions. Now, some students might not notice that the 51 is divisible by 17, and that's okay. So if you don't notice that, you can always just do cross-canceling between the 8 and the 4, and then just worry about reducing your answer at the end. And again, even if you didn't notice the 8 and 4, right, we just multiplied across the top and multiplied across the bottom. It's not the end of the world. You just have to make sure that you simplify your answer at the end. But cross-canceling can be really nice because, as I've mentioned many times before, that it can help us simplify our answer before we get to the end. So as I said, we can actually cross-cancel between the 8 and the 4. So 8 divided by 4 is going to turn this into a 2. 4 divided by 4 is going to turn this into a 1. And then you can cross-cancel between the 51 and the 17 because they're actually both divisible by 17. So 17 divided by 17 is 1. 51 divided by 17 is 3. And so now multiplying our numerators, we're going to have -3 times 1. So that's going to be -3. And then 2 times 1 is 2. And -3 halves, rewriting this as a mixed number, is going to be -1 1/2. And so there's our final answer for that question. All right, so moving into some story problems. So with this one, I have already written out our steps that we're going to need to take, but reading through the question, it says a stock market simulation project was assigned in Susanna's math class. She was given $1,000 to invest. She invested her money into a retail electronics business, and over the course of 6 months, she tracked her gains and losses. If Susanna owned 100 shares of the company, what would the average change of the value of her shares be in dollars? So in this table, we can see from January to June, so over these 6 months, the gain and loss per share. So my advice, instead of trying to figure out what this is, gains and loss per share when they're in these decimal forms, right? Let's find the overall gain and loss for 100 shares, because if we do that, what's going to happen? We're going to multiply each of these by 100. It moves our decimal point to the right 2 spots. And then you won't even be working with decimals. So we're going to do that for every single one of these. Multiply by 100 and then move that decimal point to the right 2 spots. So that negative 5 3600 multiplied by 100 is going to be negative 536. So I'm going to write negative 536. And then if I focus on my next negative, right, if I multiply that by 100, it's going to move my decimal point to the right 2 spots. So that'll turn into negative 63. So plus negative 63. Plus, and then if I look again at that last one, again, moving my decimal point to the right 2 spots because we're multiplying it by 100, because again, that's per 1 share. We want to know per 100. So multiplying by 100 is going to turn that into a negative 372. And so now we can add all of those together to find out what our overall loss was. That is going to give us negative 971. And then for the gains, same idea, right? If we multiply by 100, this is going to move our decimal point to the right 2 spots. So we're going to do that for every single one of those that are a positive value. So that $1.20 multiplied by 100 is going to be 120. So we're going to have 120 plus, again, if I multiply that $1.85 by 100, this is going to turn into 185. Plus, we have that $2.16. Again, that was per 1 share. So multiplying by 100 to figure out the amount for 100 shares, that is just going to, again, move our decimal point to the right 2, oops, wrong number. That is going to move our decimal point to the right 2 spots, and that'll be 216. So adding all of those gains together, the 216 plus the 185 plus the 120, we're going to get $521. So now we can go through and add these two together. So we're going to do negative 971 plus the 521, and we have more negatives. And again, since they're different signs, we'll subtract these two. So 971 minus 521 is going to be 450, but again, this will be negative 450 because we had more negatives to begin with. So negative $455 is the overall loss for these 100 shares. So now we're going to find the average change, because we want to know what's the average change per month in dollars. And so we just take this answer from step 1, this negative $450, and we're going to divide this by the number of months, so 6 months. And so when we do 450 divided by 6, we're going to find that our answer is negative $75 and then per month. So that is my average change. So her stocks are not doing well because they are losing money per month. Okay, so we're going to take a look at one more example in this video. And this one says, based on the average change in the savings account per week, by how much can the student expect the account to change over the course of a year? So our first step is going to be to find the total change over the 5 weeks shown in the table. I'm going to add all my positive values together, add the 2 negatives together, and then combine those 2 at the end to figure out that total change. So we're going to start off by doing the 712 plus the 673. So 712 plus the 673, and then that'll be 5, 8, and then 13, and then we're going to add the 1785 to that. So we'll have 1385 plus 1785. So combining those, that'll be 10, that's 1617, and then that'll be 11. So $31.70 for our positive values, right? So we'll have $31.70. And then for the negatives, that's not too bad to just do in our head. The $3.90 plus the $16 is going to end up being a total of $19.90, but that is going to be a negative value, right? So because those are going to be different signs, our positive and our negative, we're actually going to subtract those two. So we'll do $31.70 minus the $19.90, right? Those deductions there. And so we'll have to do a little bit of borrowing. So this is going to be 80 cents there. And then we'll have $11.80. So that is the total change over the 5 weeks. So now we're going to divide this by 5 to find the average change per 1 week. All right, so we're going to my work off to the side here. We're going to have this $11.80 divided by 5. So 5 goes into 11. That's going to be 2 times, since that's 10. Subtract, we get 1. We can bring up our decimal point. Make sure that's nice and clear there. And then we're going to bring down our 8. So 5 goes into 18 3 times. So that's going to be 15. And bring down our 0. 5 goes into 30 6 times. So the average change per week is $2.36 per week. And now we just have to take our answer from step 2, so how much per week, and we're going to multiply that by the number of weeks in a year. There are 52 weeks in a year, so we're going to take $2.36 and multiply by 52. And so multiplying that out, 6 times 2 is 12, carry the 1, 3 times 2 is 6, plus the 1 is 7, and then 2 times 2 is 4. Add our filler 0, 5 times 6 is 30, carry the 3, 5 times 3 is 15, plus the 3 is going to be 18, and then 5 times 2 is 10, plus the 1 is going to be 11. And then we'll add those two together, so that'll be 2, 7, 12, 2, and 1. And then we have to add in our decimal places. So we did $2.36, so there was 2 decimal places in there. And so we'll add our 2 decimal places back. And so writing this out so we can actually see it better, it's going to be $122.72 for how much the student can expect to have in the account at the end of the year. So that's it for this video. Hopefully that helps you with dividing rational numbers, working with both algebraic expressions as well as story problems. Thanks for watching.